Okay, a 1 mile relay race has 4 horses running a quarter of a mile each. The riders of each horse must pass a ribbon to the next rider at the end of each leg. Each of these horses has participated in many quarter mile races before, and the table below summarizes the mean and the standard deviation of their previous times. Assuming that the times follow a normal model, okay, again, when you read normal model, you can expect you may have to do a z-score. What is the probability that Night Sky can run a quarter of a mile in under 24.5 seconds? So in part A, I'm going to take Z is equal to my ZOMs, remember, observation, 24.5, minus Night Sky, which is 26.8, divided by 1.9. And that's going to give me a z-score of negative 1.21. I'm then going to go to my table at negative 1.21. So at negative 1.21, I get a p-value equal to 0.1131. The big thing you want to just look, you want to say, okay, it's in under 24.5 seconds, so you just need to remember that you do not need to subtract from 1. You only subtract from 1 if it said greater than. If it had a question between 23.5 and 24.5, you have to find 2 z-scores, go to the table, get your probability, and do the big probability minus the small. Part B, what is the probability that in the next 12 races that Night Sky enters, that he will run under 24.5 seconds in 5 of those races? What this means right now, when you see 12 and you see 5, this is my fixed number of trials. Under the 24.5, that should key into you that I'm going to use the probability from part A. We know that the probability that he's going to go from under 24.5 seconds is 0.1131. We want to know in 5 of those exactly. This is my K. So I'm going to scooch down here to really fill it out. I know it's a binomial distribution. Okay? So I'm doing a binom PDF. Why? Because the probability that X is equal to 5. What is X? The probability that he can run under 24.5 in a total of 12 races. We want to know if he can do it in 5 of those races. Okay, so he runs 12. We want to know in 5 of those races, can he run in under 24.5 seconds? So we do a binom PDF. Our N, we have 12 races. Our probability is 0.1131. And our K is 5. N, P, K. We're going to hit second bars. We're going to go to Binom PDF and we're going to calculate it. You want to be prepared that they may ask you, is this a likely event or not? Would you be surprised if it happened? Because this probability is so low, you would say that's unlikely. I would be surprised if it happened. It doesn't ask in part B, so we don't need to worry about it now. Okay, if the times of the horses are independent, what is the mean and the standard deviation of the combined team score for a 1 mile relay race? We have not covered this yet in the review. When we're combining variables, it's pretty easy with a mean. So if I'm going to take a mean and I want to combine a distribution of X plus a distribution of Y, I just add it. Same with subtraction. I can just subtract it, and I can go dot, dot, dot. With a standard deviation, though, there is a condition of independence. And then no matter what you're doing to combine, whether you're finding differences or whether you're finding sums, the standard deviation is always the same. you take the standard deviation squared of one distribution plus the standard deviation squared of another distribution, plus dot, dot, dot if you're combining more. So for this problem, I'm going to quick take a picture and send it to another page. The combined mean, I'm just going to add these all up. I'm going to take 32.6 plus 29.4 plus 37.7 plus 26.8. And I'm going to get a combined score of 126.5 seconds. It does not say this, but if it asks you to interpret, you would say, in the long run, we can expect the 4 horses to take about 126.5 seconds to run the race. Now to find the standard deviation, you do have to say independence is stated in the problem. Because in order to find the standard deviation, each observation has to be, or each distribution, whatever you're looking at, has to be independent of each other. So I'm going to take the first standard deviation, 2.5, square it, plus 2.1 squared, plus 3.9 squared, plus 1.9 squared. And I get 5.4295. Now it doesn't say to the problem, but you could be asked, interpret the standard deviation. And this is how you interpret the standard deviation. A standard deviation is the average distance observations are from the mean. So in this case, you could say, on average, we could expect the combined score to be about 5.4295 seconds from the mean.